Boys and girls, this is Mr. Manise here with another super cool video, and in this video I'm going to walk you guys through how to solve all of the problems on the second quiz review for chapter 10 with our exponents with some radicals thrown in this time. And as always with my disclaimer, if you have not worked through each of these problems, please pause or stop the video, work through the problems yourself, then come back and play the video and see if you can clear up any misunderstandings or mistakes that you might have made. The analogy I always use is guitar. I can't teach you how to play guitar if you do not pick up the guitar and play it yourself. You can watch me sit there and play guitar, and that will scratch the surface and get you started, but you actually have to put your fingers on the fretboard and practice yourself, whether it's math or volleyball or whatever, painting, whatever you're doing. You've got to practice this stuff over and over. Okay, so don't watch this video until you've worked through each of these problems. Alright, so before we get started, I'm going to throw this in here. This is very, very important for this video. And this, my friends, is simply, who is that? I'm not sure who that is. It might be Mr. Deshaun Watson, the quarterback of the 2016 National Football Championship team for the Clemson Tigers. That's just how they roll. That's it. Now, if you're watching these videos and you're kind of wondering to yourself, man, am I going to have to put up with all this Clemson stuff all year long? Yes. Let's get started. All right, here we go. Number one, we have some more exponent rules. Let me jump in, and I would strongly encourage you guys to get out your graphing calculators, because I'm going to continue using this little trick that I've taught you guys on how to check these, whether it's exponents or radicals or polynomials. This stuff works for all kinds of algebra-based problems where they ask you to simplify. You're taking one complex form and you're simplifying it to another form. Okay, so here we go. Number one, we have 2a squared times 3a to the negative 3. I'm going to use my same little three-step brain process that I mentioned in class and in my last video. Signs, coefficients, variables. Get those right in that order. I don't have any negative signs here, so I don't have to worry about that. Coefficients. Multiply the two coefficients together. All of this stuff is being multiplied together. So I simply multiply those and get 6. Now here I have the product rule. I have apples and apples. None of these exponent rules apply if you don't have matching bases. In this case I do have A's and A's. I have apples and apples. So here I simply add my exponents together with a product rule. 2 plus a negative 3 is 2 minus 3, which is 6a to the negative 1. A bunch of old people got together many, many years ago, said, "Thou shalt not leave this in your answer." And we said, okay, whatever, fine, we'll do it. So we've got to flip that guy. So we're going to have to put that on the bottom. So the a to the positive. It's not wrong if you put a 1 here. I certainly won't count off for that, but you don't need to write that understood 1. Let's check these for purposes of this video and sake of time. I'm not going to check every single one of these, but I do encourage you guys to check every single one as you're working through these homework and review problems, and definitely on test and quiz days. I'm always amazed at how many students turn in their test and quiz 25 minutes early, and they have a golden nugget right there at their fingertips with their graphing calculator to check these types of problems, and they just don't do it. I'm not really sure why, and that's one of the main reasons or differences between A's and B's and C's and other stuff. Okay, so let's type in our original problem. 2 alpha A. Now I don't have to press raise to the second, I just press the square button. Now once again, I mentioned this in my last video. If you've got one of the older model, one of the newer model calculators, 3 alpha A raised to the negative 3. Notice that your cursor remains up in the exponent. So when you're typing this stuff in, you got to make sure you drop that back down as you continue in the problem. Alright, so here I'm just going to press enter and I get some number. Guys, I don't care what that number is. 2,006,58934. I don't care. I just want to make sure it matches what I think my final answer is. We think that that's equivalent to 6 over a. Well, let's type in 6 over a and see if we get the same answer. 6 divided by alpha a. That better be 2. Ta-da! Bam! Love it. Move on to the next problem and feel confident that you didn't make any careless mistakes. If you're not sure how to set this up, I've got a couple of different videos on how to program your calculator to store numbers and assign numbers to every letter on your calculator so you can use this trick. And guys, we'll be using this trick for a long, long time. So don't think that you're going to use this trick the first week and you're done with it. We're going to use this all year. You're going to use this, hopefully, use this next year in advanced algebra. Okay, move on to the next one. Signs, coefficient variables, no negatives. Coefficients, 2 times 3 is 6. Variables, add the exponents. That's the product rule. 3 plus 4 is 7. So I get 6 feet to the 7. I'm not going to check that. You guys can check that one. Now here, whenever you don't have an exponent there, remember that's an understood 1, so don't discount that. Signs, coefficients, variables, and no negatives. Coefficients, 3 times 3 is 9. And then here I got the product rule again. I need to add the 1 plus the 2. That gives me n to the third. Okay, you guys check that one, please. Okay, now remember, anything raised to the 0 is a big fat 1, but you got to pay attention to where the parentheses are. The 0, in this case, is the exponent only for the y. Only the y is being raised to the 0. If the 0 were outside the parentheses, then everything inside the parentheses would be raised to the 0, but it's only the y. So only the y to the 0 becomes a 1, which essentially means you can just scratch it out, because anything times 1 is just itself. So basically all I have is 2 raised to the third power. 2 times 2 times 2, which is 37. Just kidding. Just kidding. 8. Alright, let's move on to the next one. I have parentheses 2x squared raised to the negative 2. Now here you got two different roads. You can go left or right, and I can't tell you which one is better. That's why I love math. Lots of different ways to do it. You got to do what's most comfortable and best suits you. I could go ahead and raise everything inside the parentheses to the negative 2. I can do that. But 2 raised to the negative 2, some of you guys might not know immediately what that is off the top of your head. And when you type that in your calculator, 2 raised to the negative 2, you get, what? 0.25. What in the world? Now, if you want to convert this to a fraction, you got to go up here and press the math button. Math. This is a math class after all. Math fraction, option number 1, just press enter, and then press enter again, and your calculator will convert any decimal to a fraction if it's possible to do that. That seems like a lot of work. So in this case, you can do that. But to me, when I see these negative exponents outside the parentheses, if there's a coefficient inside, I don't want to mess with raising a coefficient to a negative value. So to me, I'm just going to take this whole thing, I'm going to take the whole thing and flip it, put it on the bottom. So I've got the whole thing, 2x squared in parentheses raised to a positive 2. Now I don't have to mess with nasty negative exponents. Well, what's left on the top? Smiley face? Truck? 0? Just a 1. Just an understood 1 right there. Now I can continue with the problems, not so bad. 2 raised to the 2, 2 squared is 4. 2 times 2, that's the power rule. Multiply your exponents is x to the 4th. And I never had to mess with nasty negative exponents. Okay, let's check that one real quick. It's a pretty easy one. All right, so I got 2x. Well, let's do exactly the way I said, parentheses 2x squared, parentheses. Make sure you guys can see it in the video. Raised to the negative 2. Don't care what that number is, 5.47 to the negative 7 power. Fine, don't care. We think that's equivalent to 1 over 4x to the 4th. Okay, 1 divided by, now if you guys remember my last video, is crucial. If you have more than one thing in the denominator, you got to put all that mess in parentheses. So 4x raised to the 4th, drop my cursor back down. All of that has to be raised, all of that has to be in parentheses, okay? That better be the same thing as 5.4. Ah, there you go. Bam. We did it right. Love it. Move on to the next problem. Okay, so here we got the power rule again. I'm just going to multiply my exponents. Negative 4 for the x times 3 is x to the negative 12. 2 times 3 is y to the 6th. Can't leave that in my final answer. Got to flip that guy, put him on the bottom. So that's going to be y to the 6 on top, and that's going to be x to the positive 12 on the bottom. You guys check that one, please. Okay, number 7. Okay, now here in the denominator I have understood 1s there. I'm perfectly fine with you guys writing a little 1 if that helps you. If you're a student who maybe your math has not been your strong point over the years, you make a lot of careless mistakes, anytime you can add stuff to your diagram, write stuff there that just helps your brain focus and not make careless mistakes, I'm a huge advocate of doing that. So please feel free to do that. Alright, signs, coefficients, variables. I don't have any signs. I only have one coefficient. So I know there's going to be a 2 in the top. Now here we got the quotient rule. I got apples on top, apples on the bottom. Oranges on top, oranges on the bottom. Okay, so what do I do with my exponents with the quotient rule? I subtract top minus bottom. 2 minus 1 gives me an m. to the positive 1. I don't have to write the positive 1, but if that helps you, then you're welcome to do that. For the n's, subtract 4 minus 1, that's n to the third. So my final answer is 2m n to the third. I chose not to write the little 1 there for the m, but you certainly can. Okay, signs, coefficients, variables. I don't have any negative coefficients. I only have 1, 3, so I know there's a 3 in my final answer on top. Now here it's a little tricky. I'm going to do top minus bottom, but notice I have a negative exponent in the bottom. So when I subtract, that's going to be u raised to the 2 minus a negative 3. Whenever there's a negative in the bottom, that's going to make that a double negative. That's going to make that a positive. And then for the v's, that's just simply 5 minus 2. Okay, so my simplified answer will be 2 minus a negative 3. That changes to 2 plus 3, so that's going to be a u to the 5. And then for the v's, it's just 5 minus 2. So v to the third. Okay, let's check that one. I want to ingrain in your brain the importance of using this little calculator trick to check your answers. So you can take those c's and b's and turn those into b's and a's. Okay, so let's enter in the problem exactly the way that we see it. 3 alpha u squared alpha v raised to the 5. Drop my cursor back down. I got more than one stuff in the denominator, so I got to put all that in parentheses. Alpha u raised to the negative 3. Drop my cursor back down. Alpha v squared. Close the parentheses. I get some number. 2.6 with 11 zeros behind it. Wow, wish I had that much money. That's not going to happen. All right, let's type in our simplified answer. 3u to the 5th, v to the 3rd. 3u to the 5th. Drop my cursor back down. V to the 3rd. That better be the same thing. Ta-da! Bam. Move on to the next problem. Don't have to wonder. Don't have to guess. Guaranteed. Okay, so let's move on to number 9. V squared raised to the negative 2. That's the power rule, so I just multiply those together. That gives me v to the negative 4. Now over here in the second set of parentheses, the 2 is being raised to the 4th. Don't forget that. 2 times 2 times 2 times 2. That's going to give me a 16. Then for the u's, I multiply the exponents. That's the power rule. 4 times 4 gives me u to the 16. Negative 1 times 4 gives me v to the negative 4. Now you could be thinking to yourself, okay, I need to flip those guys. But before you do that, you need to realize that, hey, I can use the product rule here. I've got apples and apples. I can go ahead and combine those. I can go ahead and add those two exponents together. So I have the 16 u to the 16, and then when I add negative 4 plus a negative 4, that's negative 4 minus 4, which is v to the negative 8. I can't leave that guy because it's a negative exponent. I got to throw him on the bottom. So the 16 u to the 16 stays on top, and that's going to be a v to the positive 8 on the bottom. Okay. All right, you guys check that one. Okay, over here, 2y times x to the negative 4, y to the negative 4, raised to the negative 4. Okay. Well, can't do anything with the 2y squared, so we'll just keep that. Now here, I told you earlier in the video that I like to take this and throw the whole thing on the bottom, but that's really only when I have a coefficient in the parentheses. Here, there's really no reason to do that. I can just go straight to the power rule. Negative 4 times negative 4, and that gives me x to the 16. Negative 4 times negative 4 gives me y to the 16. And then all I have left to do is combine my apples and apples. That's the product rule. Just add those exponents together. So I still have my 2x to the 16. 2 plus 16 gives me y to the 18. And we're done. So you see in this case, if you would flip this whole thing on the bottom, you'd get the same answer. But you would be ended up having to flip backwards. And the main reason I like to flip is because I don't like to raise coefficients. I don't like to raise numbers to negative exponents. Okay, so in this case, I probably wouldn't flip that whole thing. Let's check that real quick. Check it, check. Okay. All right, so we have the original problem is 2 alpha y squared. I don't need to press times. My calculator knows parentheses and it knows that's multiplication. X raised to the negative 4, drop the cursor down. Alpha y raised to the negative 4, drop the cursor down. Close the parentheses and all that raised to the negative 4. Just like that. Okay? Bam, some number. Holy cow, 48 zeros. My goodness. Okay. 2x to the 16, 2x raised to the 16, drop the cursor down, alpha y to the 18th. That better be 48 zeros. Bam, it is. Ta-da. Next. Okay, a squared, b squared to the negative 2, so when I multiply those, again, I don't have any coefficients, so in this case I'm probably not going to flip the whole thing. Let's just go a to the negative 4, b to the negative 4, and then we have over here, same thing, I've got a times a to the negative 4. Okay, well, I've got apples and apples. So when I add those together, that gives me a to the negative 8, and I got the b to the negative 4, but I can't leave that. I got to flip both of those guys on the bottom. So I flip that, so there's an a to the positive 8 on the bottom, and b to the positive 4 on the bottom, and what is left? What do I have on top? Smiley face? Frowny face? 1. That is my final answer. Okay, now we got 3 variables, no problem. Anything raised to the 0 is a big fat 1, so just scratch that out. So I have, let's put these in alphabetical order, x to the 4th, z. Now remember that everything in the parentheses is being raised to the 4th. 2 to the 4th is 16. 2 times 4, that's the power rule, that's x to the 8th. 4 times 4 gives me z to the 16. Now I've got apples and apples and oranges and oranges. So I have this 16 coefficient out front. I add the 4 plus the 8. That gives me x to the 12th. I add, there's a understood 1 there. 1 plus 16. That gives me z to the 17. Okay. Let's check that one since that's got a 0 in it. Okay, so let me zoom out here so you guys can, a little bit easier to see what I'm typing in. Okay, so alpha z x raised to the 4th, drop my cursor down, alpha y raised to the 0, drop my cursor down, parentheses 2 x squared, alpha z raised to the 4th, drop my cursor down, all of that raised to the 4th, get some number, 42 zeros, nice. 16x to the 12th, z to the 17th, 16x to the 12th, drop my cursor down, z to the 17th, bam, 42 zeros, like it. Okay, coming down the home stretch on the front side here, got a bunch of stuff. Alright, so I can't really do anything with that. B to the 0 is 1, so I just have a to the 3rd, c to the negative 1, same thing here. 2 to the 4th is another 16. You guys ought to be getting good at that. 2 times 4, a to the 8th, 3 times 4, b to the 12th, 4 times 4, c to the 16. Now let's add our apples. Add those together, that's a to the 15. Oh, I'm sorry. Yeah, okay, that's right. Alright, so I was looking at the wrong one. Okay, so 8 plus 3, that gives me a to the 11. For the b's, I just have a b to the 12th. And for the c's, I'm adding a negative 1 plus a 16. That gives me c to the 15. Okay. So 16, a to the 11th, b to the 12th, c to the 15. Okay. Anything raised to the 0 is a big fat 1. So I basically have 1 to the negative 2. 1 raised to any power is a big fat 1. So this whole thing is just a 1. So I just have 3 cubed, which is 27. That's pretty easy. Okay. Check it out on the back. Scientific notation. I kind of put this on here. I wanted to talk about a little bit, may or may not be on the quiz or test, but this stuff that you should know, especially for your science classes. And this is just simply typing this in on your calculator. So how do I type in scientific notation on my calculator? Zoom out here. You just use this little, see the little double E button right here where my finger is above the comma? That double E just means scientific notation. That means times 10 to the whatever, okay? So if I want to type in 3.5 times 10 to the 3rd, I'm going to press 3.5, and I press this blue and this second E button. Second double E. See that little E? That just means times 10 to the whatever, all right? So we want times 10 to the 3rd power, so I just do 3. So 3.5 e to the 3 is the exact same thing as 3.5 times 10 to the 3rd power. And then times 9.82 second double e to the negative 2, and I get this number. So 9.82 times 10 to the negative 2. I get 343.7. Okay, well, we can't leave that as scientific notation because, remember, scientific notation, the first digit has to be above 1 and less than 10. Okay, so I got to move this decimal 2 places to the left. So this actually ends up being 3.437. When you move the decimal to the left, the exponent goes up. So that's times 10 to the second power. When you move, of course, when you move the decimal to the right, the exponent goes down. Most of the time, though, your calculator will put it in scientific notation for you, like it's about to do on this one. So this is quite easy. So let's just go 8.7 second double E to the -1 divided by 1.3 second double E to the 5, and there you go. It does all the work for us. So that's, I'm going to round that to 6.69. 6.69 times 10 to the -6. Since it has the little, you see that, since it has the little e to the -6 there. So that's really nothing to it for scientific notation. Okay, a couple more, and then we get into the radical stuff. Okay. All right, so a little tricky here. We got some combo stuff. We got power rule. We got product rule. We got quotient rule. We got Mr. Manish rule. Whatever. Okay, b squared, can't do anything with that. So got a b squared on top. Okay, now here I do have a coefficient raised to a negative. Ugh, don't like that. So let's take this whole guy and put it on the bottom. 2b raised to the +1 on bottom. And then I still have this times 2b squared on the bottom. Okay, b squared stays on top. All right, 2 times 2 is a 4. And I have a b to the 1 times a b squared. So what do I do with those exponents? I have to add them together. 1 plus 2, that gives me a b to the 3rd. Okay, so now I have a b on top, I have a b on the bottom, apples and apples. What do I do with that? I subtract my exponents. So when I subtract, I have 2 minus 3, which is a b to the -1. Now remember, when you do the quotient rule, whatever answer you end up with when you subtract top minus bottom, that guy always starts out initially on top. And if it happens to be negative, then yes, you have to flip it and put it on the bottom. So we still have the 4 on the bottom, so here, yes, we do have to flip it and put it right back on the bottom. So I have a 4b to the +1, and what's left on top? You got it. Big fat 1. Let's check that one. That was kind of a little tricky. A lot of stuff going on there, even though it looks like a simple problem. Okay, so let's type in alpha b squared parentheses 2 alpha b. All of that raised to the -1. Drop my cursor down, divided by, I got more than one stuff in the denominator, so I need parentheses 2 alpha b squared, parentheses, I get some number, 0.065, okay? We think that's the same as 1 over 4b. 1 divided by parentheses 4 alpha b, bam, 0.0625. Never get tired of it, never. Okay, this is a little tricky because you have a negative inside the parentheses that's being squared. If you remember from my last video, I refreshed your memory. When you raise a negative to an even power, it's always positive. You raise a negative to an odd power, it's always negative. So when I square that negative, I get a positive, and then I'll just multiply using my power rule. It gives me v to the 4th. Now down here, here's where I use my little 3-step process. Signs, coefficients, variables. I see a negative and another negative. Get those signs right first. Negative times a negative is a positive. Then coefficients. There's no other coefficient other than a 2. Now we go forward with the variables. I got a v to the 1 times a v to the 1 times a v to the 2. I add those. 1 plus 1 plus 2 is v to the 4th. And I have a v to the 4th on top and a v to the 4th on bottom. Whenever you have something on top of itself, bye-bye, see you later, they cancel. So I have a 2 on the bottom, and what am I left with? You got it. A 1. So my final answer is 1/2, 50%, 0.5. Here we go, radicals. This is kind of the area where students tend to trip up a little bit more on with radicals, simplifying radicals, and operations with radicals. Now, if you remember from our lesson, when you're simplifying a square root or a cube, we're going to break it down into perfect land and non-perfect land. And I've made a couple little cheat sheets over here for our perfect squares just to help refresh our memory. Whenever I'm simplifying a radical, when I'm doing a square root, I'm looking for the highest perfect square. What are our perfect squares? 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, 64, 81, 100. You guys should be very, very comfortable with being able to just rattle these off in your head and not have to think too much about it. Okay. I also have a little cheat sheet for perfect cubes. 1 cubed is 1, 2 times 2 times 2 is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125. You should have those first 5 committed to memory in your mathematical toolbox, in my personal opinion. So here we go. Number 1, how do I simplify the square root of 96? And guess what, guys? You can use this little calculator trick on this stuff too. You see that word right there say? Simplify. You can use the trick dealing with numbers and algebra. Okay, so I got to break this down into perfect land and non-perfect land. Well, how do I know whether it's a perfect square or a perfect cube? Well, I'm looking right here in that little crevice of the square root symbol. If there's nothing there, what is it understood to be? It's understood to be a 2. So here we go. I'm going back to my little cheat sheet. I'm looking to see which of these perfect squares, I'm looking for the highest perfect square that divides evenly into this number. Okay, and some of you guys, it might not be that clear what highest number goes into it. And if you're not sure, just use your calculator. Okay, so we need the highest one. So 4, that probably goes. Let's try it. Let's type it in. 96 divided by 4. Does that go? Sure does. It goes evenly. Okay, what about 16? Does 16 go into it? 96 divided by 16? Oh, sure does. That's even. What about a higher number? Obviously, it's got to be even. Let's try 36. Does 36 go into 96? Oops. 36 go into 96? Nope. That's a decimal. So if it's a decimal, it doesn't divide evenly. What about 64? Does 64 go into 96? Nah, it doesn't. Okay, so that tells me right there the highest perfect square that goes into 96 is the 16. That's a great way to check it on your calculator instead of trying to do all this stuff in your head. Okay, so I'm going to break this down into perfect land, perfect, and garbage, trash, non-perfect. So I'm going to keep my square root symbols with me. Okay, perfect land, non-perfect land. What goes into perfect? 16. How do I know it's perfect? Because I wrote the word perfect right there. 16. That's a perfect square. Now, to figure out what's left over, what goes in the garbage can, the non-perfect, I just simply divide the radicand by the perfect square. So we said that 16 goes into 96 how many times? It goes into it 6 times. Okay, so 6 goes in the garbage can. Okay, that's my non-perfect stuff. I cannot take the square root of 6. It's some decimal. Okay. Now, the whole point of doing this is because I can simplify perfect land. What is the square root of 16? It's 4. And then I can't do anything with the garbage, so I just leave the garbage alone. So my final answer is 4 times the square root of 6. Okay, guess what, guys? I can check it. I can check it. Type in the square root. Now, how do I get the square root? Square root is in blue above the x squared button. Let's type in the square root of 96. I get some number. Don't care what the number is. We are saying after we simplify that, that is equivalent to 4 square root of 6. Is it? Oh my gosh, it is. It actually is. Bam. Love that trick. Number 20. What is that? That's a square. There's nothing there, so that's understood to be a 2. What is the highest perfect square that goes into 72? If you're good at math, you'll be able to do this in about 1.2 seconds. If not, use your calculator. It just so happens that 36 goes into 72 how many times? It goes into it twice. Okay, so I'm going to abbreviate perfect, non-perfect. So 36 is a perfect square. And what's the leftover garbage? 72 divided by 36 is 2, because 2 times 36 is 72. What is the square root of 36? It's 6. So this just simplifies as 6 square root of 2. Okay, check it. Square root, you can check these lightning fast. Square root of 72, and then 6 root 2. Bam, they match, they match, they match. Now, one mistake that I will see that students will make here is they won't pick the highest perfect square. And when you use the calculator trick, they will match. However, you got to make sure you pick the highest one or you haven't completely simplified it. Okay? So, for example, let's say you picked 4. Let's say you broke down the square root of 72 into the square root of 4 and the square root of 18. Okay, and then you said that that was equivalent to 2 times the square root of 18. Well, when I check this on my calculator, 2 root 18, guess what? They still match. However, I didn't simplify it all the way. How do you know whether you've simply simplified it or not? If you still have a perfect square inside your answer, then you haven't simplified it enough. Is there one of these numbers? Are there any of these numbers that go into 18? Yes, there is. 9 goes into 18. So, oh man, I must not have picked the highest number. Okay, so keep that in mind. But if you don't simplify it all the way, I personally won't count the whole thing wrong. But all right, so here we go. Perfect land, non-perfect land. We just did 72, so I know there's a 36 in here, and I know that's perfect, non-perfect, and I know there's going to be 2 in the garbage can. Now with the b's, with the variables, now remember, if it's a square root like this one is, if it's an odd exponent, you must drop it down to the next lower even exponent. Okay, so I've got to drop the b cubed, I've got to drop that down to a b squared, because any exponent raised to an even power is a perfect square, and we talked about that in class. So I got to drop this down to a b squared. Now if I drop it down 1, how many will be left in the garbage can? And that is not a trick question. 1. So I got to put 1 of the b's in the trash can, in the non-perfect land. I can simplify this. Yes, I can simplify this. No, I cannot simplify this. So what is the square root of 36? 6. And what is the square root of b squared? So remember, whenever you're taking a root of an exponent, you just simply divide the 2. There's an understood 2 here. So when I divide 2 by 2, I just get 1. So the square root of b squared is b. Doesn't that make sense? Because b times b is b squared. So the square root of b squared is simply b. Okay. So after I simplify the perfect land, I get 6b. And in the garbage, I can never simplify the garbage. So that will always, the garbage can, the non-perfect stuff will always be the caboose in my final answer. Let's check it. Square root of, I'm going to always remember, you gotta make sure you guys can see this. Square root of 72 alpha b raised to the 3rd, get some number, and we're saying that's the same thing as 6 alpha b square root of 2b. Man, what a good feeling that is. What a good feeling that is. Okay, perfect land, non-perfect land is, are there any of these numbers that go into 144? Well, I stopped a little bit short. 11 squared is 121, and what is 12 squared? You guys should know, really you should know up through 15. Okay, but definitely you guys should know from elementary school up through 12. Okay, 144 is a perfect square, so the whole thing goes in the perfect land. Perfect, non-perfect. Okay, so that means there's no coefficient in the garbage can. Now x, that's an x to the 1. Now, it's not an even one. I can't drop it down any lower, so there's simply just a single x that goes in the garbage can in the non-perfect stuff. The square root of 144 is 12, and I'm always just going to simply pull over the non-perfect stuff. 12 square root of x. Okay, square root of 18x squared y. Let's go perfect, and let's go non-perfect. What's the highest of these numbers that go into 18? That should be pretty easy. That's 9. So 9 goes in perfect land. Now x squared is already even, so I just put the whole x squared in the perfect, on the perfect side. Y to the 1, we just said we can't do anything with that. Okay, now if I put a 9 in the perfect, what is left over from 18? 18 divided by 9 is 2, so 2 goes in the garbage can. The whole x squared went over here, so the no x is here, and the single y goes in the garbage can. Okay, I can simplify that. I cannot simplify that. So my final answer, the square root of 9 is 3, and the square root of x squared is just x, and then I have the garbage can, the non-perfect stuff. That's always in the back end of my answer. Okay, check, 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 check. Square root of 18 x squared alpha y, and 3x, can you see that? 3x square root of 2 alpha y. Whoa, I didn't type that in right. 3x square root of 2 alpha y. Thank you. And we do get the same two numbers, 573. Okay, 32x cubed y cubed. Perfect. Non-perfect. What's the highest of those numbers, perfect squares that go into 32? 16 goes twice. So 16 goes in perfect twice, so the 2 goes in the garbage. X cubed, I got to drop that down 1, so x squared goes in the perfect side, which means a leftover x goes in the garbage can on the non-perfect side. Same thing with the y's. Drop that down to an x squared, throw a single y in the garbage can. I can simplify that. I cannot simplify that. Square root of 16 is 4. Square root of x squared is x. Square root of y squared is y. And then I got the garbage can. Can't do anything else with that. Bam. Check that one for me, please. All right, now before we move on, there aren't any perfect cubes on the quiz review, so therefore I do want to do one of these, s'il vous plaît, just to make sure. There may be a cube on the quiz or the test. Hint, hint, wink, wink. You can't see me winking in the camera, but I am. All right, so it's the same concept, but now this time, instead of looking at perfect squares, I'm going to be looking at these bad boys, perfect cubes. Okay, I still have the same concept: perfect land, non-perfect land. Okay, so I'm simply looking, what is the highest of these numbers that go into 128? Okay, well, some of you guys may be good at that. Let's try 27. 128 divided by 27. Does that work? That's a decimal. That doesn't work. Let's go a little higher. 128 divided by, let's try 64. Ding, ding, ding. We have a winner. Yes, it does. It goes 2 times. Obviously, 125 doesn't go into 128 evenly. So perfect is going to be, now remember, I'm dealing with cube roots. Okay, so everything is cube root. Perfect land and non-perfect land is cube root. Okay, so 128 is divisible by 64. That's a perfect cube. So what goes in the garbage can? 128 divided by 64 is 2. Now here, now with the squares, we drop that down to the next even value, right? Because any even exponent is a perfect square. With cubes, we can't do that. With cubes, we're looking for multiples of 3 or groups of 3. Okay, 7 is not divisible by 3, so we need to drop it down to the next lower exponent that is divisible by 3. Okay, if in this case we're dropping it down by 1. If this were an exponent of 8, we would not need to drop it down by 2 to get down to an exponent of 6, since that's divisible by 2. So let's drop this down by 1. So I'm going to put an x to the 6 because that's divisible by 3. Okay, remember, perfect cubes have to be divisible by 3, which means how many x's will be left over? I dropped it down by 1, so I'm going to stick a 1 x in the garbage can. Okay, this I can simplify, this I cannot. Okay, so what is the cube root of 64? The cube root of 64 is 4. Okay, 4 times 4 times 4 is 64. Now here, once again, I'm going to divide whatever exponent I have, divide it by the root that you're taking. In this case, we're taking the third root. We're taking the cube root. Okay, so I simply divide 6 by 3, and I get 4x to the third. Okay, and then I have the leftover garbage can. Okay, so I just have times the cube root of 2x, and that is my final answer. Okay, let's check this. Okay, now here, if I want to do the cube root, I've got to press this math button. See the math button right here? Math. Now scroll down, you see this right here? Option 4, that's the cube root. So I can either just press 4, or I can scroll down to and press enter. So now notice there's a little 3 right here. So I want to take the cube root of my original problem, 128x raised to the 7th, get some number. Okay, fine, whatever. 10,092. All right, let's type in our simplified answer. 4x raised to the third, drop that down, times math cube root of 2x. Now, I'm not going to press the enter button. I did this on purpose, guys. I intentionally made a mistake on purpose. Watch. Uh-oh. They don't match. That's why this trick is so critical. You will catch almost all of your careless mistakes, unless you just flat out don't know how to work the problem at all, which that's a whole different issue, but this will catch your mistakes. So I got to go back and say, wait a minute, what did I do wrong? Oh, I know what I did wrong. I'm supposed to divide the exponent by the root. 6 divided by 3, that should be a 2. I found my mistake. Now when I go back and type in the correct answer, 4x squared times math, the cube root of 2x, we return to glory, because now this matches the original problem. And that, guys, is such a critical part of catching careless mistakes for a lot of the stuff that we're doing with algebra. Okay, home stretch, stay with me. I know this is a long video, but there's a lot of stuff in here. All right, operations with radicals. And again, guys, if these videos are too long for you, you don't necessarily have to watch the whole thing. Just kind of pick and choose and scroll through and fast forward and jump to whatever problems you think you need. If you work through the review and you only have problems with 2 of the problems, just go straight to those 2 problems. You don't have to watch the whole thing. Okay, so when I'm adding and subtracting radicals, I want you to think about this as combining like terms, combining apples and oranges. You guys have been doing this since middle school. Well, I have -3 apples right here. I have apples and oranges. So on the surface, it doesn't look like I can do anything. But when you're doing these operations, adding and subtracting, you got to make sure that the radicals are fully simplified. Well, this is a square root because there's nothing there, there's nothing there. So we're back to this guy right here. Which of the highest of these numbers go into 12? Well, there aren't too many options. It's 4. Okay. So I'm going to break this down into perfect land and non-perfect land. Okay, but I'm only doing this on the square root of 12. The -3 is just going to stay out front for the time being. So when I break that down into perfect land, another mistake that I see students doing is they forget to bring down the radicals. They simply bring this down to 4 and 3, and they multiply these and get 12. And these are radicals. Okay, the square root of 4 times the square root of 3. Okay, so this, and then of course I just have the minus square root of 3. And I still got this -3 out front. We'll deal with that in a second. Now the square root of 4 is 2. So I have 2 times the square root of 3, but I'm multiplying that front coefficient, the -2 times this new 2 that's been created. I got to multiply those signs, coefficients, variables, or in this case radicals. So -3 times 2 is actually going to be -6 times the square root of 3. And then I still have out here, still bring this down, minus the square root of 3. So let's recap what happened. We converted the square root of 12. We broke that down into root 4 times root 3 because 4 is a perfect square. The square root of 4 is simply 2. So the square root of 12 simplifies to 2 root 3. But I got to multiply 2 root 3 times this -3 out front. So when I multiply -3 times 2, that gives me -6 root 3. And now I have apples and apples. Or dollars. I have -$6 minus $1. How many dollars do I have in my checking account? I have -$7, or -7 of these. I have -6 of these things minus 1 of these things. I have -7 of these things. Okay, so -7 root 3. Check that on your calculator. -3 root 12. Move my cursor over. Minus root 3. Okay, fine. Can't see that. And then -7 root 3. So quick. I mean, we did that. I did that in like 7 seconds. Okay, so home stretch. Negative square root of 27. Which of these numbers go into 27? 9. So this breaks down into negative square root of 9 times the square root of 3, because 3 times 9 is 27. Square root of 12, then I have plus 2. This breaks down into square root of 4 times square root of 3. We just did that one. Square root of 9 is 3, so I have -3 times the square root of 3 plus square root of 4 is 2. And 2 times 2, we've got to multiply these two guys together. 2 times this 2 that's already out front is 4. Plus 4 times the square root of 3. Okay. So now I have -$3. I have apples and apples. Apples, apples. I have -3 apples plus 4 apples. How many apples do I have? I have 1 apple. Or I just have 1 single square root of 3. Okay, last concept. When I multiply, this is like distributive property. You guys know how to do this, but instead of variables and letters, we're dealing with radicals. I simply distribute the square root of 5 times square root of 2. When I do that, I just simply multiply the two radicands together, the two numbers inside the square root, and I just simply get square root of 10. When I distribute 5 times the square root of 10, I get plus the square root of 50, but we're not done because I got to see if I can simplify. I can't do anything with 10. Are there any of these numbers that go into 50? Yeah, 25 does. So I can break this down into perfect and non-perfect. 25 is perfect. The leftover garbage 2 is not. So I have the square root of 10 plus the square root of 25 plus 2. And the square root of 25 is just 5. So this simplifies as the square root of 10 plus 5 times the square root of 2. Okay, let's check that. This will be the last one I check. Type in it exactly the way you see it. Root 5, move my cursor over, parentheses root 2, move my cursor over, plus root 10, move my cursor over, and then parentheses. Okay, fine. We say that's root 10 plus 5 root 2. Root 10 plus 5 root 2. What a wonderful feeling. Okay, last one. Now here it gets a little sticky because we have coefficients in front. So here again, this is why it's so critical. I use my little three-step process. Signs, coefficients, variables. I'm still going to distribute, okay? But when I distribute, get the signs right first. Negative times a negative is a positive. Coefficients, 4 times 4 is 16. Then variables, or in this case radicals. Root 10 times root 10 is root 100. Now I've got to distribute negative 4 root 10 to the positive 3. Signs, negative times a positive is a negative. Coefficients, negative 4 times 3 is 12. And then root 10 times 1 is just root 10. Okay. Now the square root of 100 is 10. So this is just 16 times 10 minus 12 root 10. And 16 times 10 is simply 160 minus 12 root 10. And I cannot do anything else with root 10 because there's no perfect square that goes into 10. And that, boys and girls, is going to be it for this video. Hope you enjoyed it. Hope you learned some stuff and ironed out any kinks in the armor. And look forward to seeing you guys on the next one.